Hey calculus kids, welcome to week 6 Tuesday. Go ahead and pause the video and go ahead and answer the following 3 questions. This is week 6. This warm-up blog is due on week 9 Friday. It is going to be worth 300 points. 100 points specifically for the warm-up blog itself, so make sure you have about 100 boxes filled out. All right, if you take a look at question number 3, I have 2 of the questions from your guided notes yesterday when it comes to special trig theorems. I had you guys go ahead and do number 10, 11, 12, and 13, and I'm going to go ahead and go over number 11 with you guys. All right, so as I am looking at this right here, I can see that I need to go ahead and rewrite this somehow, because if I go ahead and plug direct substitution, it is going to result in a 0 in the denominator. So my strategy is that I would probably have to rewrite this tangent, because I know a tangent could be written as a sine over cosine. But then also, if I were to go ahead and maybe utilize one of the theorems, another way I can go and replace the 1, and this is a little bit weird, is cosine x over cosine x. And it's totally legit because it's just a 1. Cosine x divided by cosine x is 1. So then what you're going to have here is you're going to have a fraction cosine x minus sine x divided by cosine x once you add the fraction together. Now, I could say this fraction is then going to be divided by the denominator, but I don't want a fraction on top of a fraction, so I'm going to go ahead and multiply it by the reciprocal, change it into a multiplication, like that. Immediately what I notice is that I see that the numerator of the first fraction is very similar to the denominator of the second fraction, and if I just factor out the negative 1, then I will be able to have a sine x minus cosine x, which is great because then I can go ahead and cancel this, which would give me a negative 1 over cosine x, which means if I were to go and apply the limit directly, it would not be on the line, which will then give me 1 over cosine pi over 4, which is, if you remember the unit circle, at cosine pi over 4, square root 2 over 2. And again, you were faced with a fraction on top of a fraction, so 1 times 2 over square root 2, or just, and you know what, I forgot the negative, sorry, somewhere along the way, got lost. Negative 2 divided by square root 2. You don't want to have a radical in the denominator, so I'm going to multiply by square root of 2 top and bottom, which will give me a negative 2 square root 2 over 2, which is a negative 1 square root 2. And that will be my answer. Let's take a look at number 12. Okay, so with number 12, you see this, and immediately going back to trigonometry, one of another formula is sine squared x plus cosine squared x equals 1. In pre-calculus and trigonometry, you guys know how to rewrite things back and forth, etc. So immediately, if I were to rewrite this, to me, it seems like sine, and that looks like a really bad sign, sine squared x is going to equal to 1 minus cosine squared x. And so that's something that just came to mind. I know if I use direct substitution, it will result in an undefined. So strategically, we need to go ahead and do something about this so that way we can get to that goal. All right, so then looking at this, I'm going to go ahead and replace the numerator with this new formula, with a new conversion, sine squared x over 2x squared. Now this looks a little bit better. And which one am I going to use with the special trig theorem? Well, there is one that we went over, and this one comes to mind. As x approaches 0 for the limit, sine x over x equals 1. So then what that means is I need to go ahead and split this fraction into 2. So I have sine x over x times sine x over x times 1 over 2. So excuse me, 3 fractions. So that when I go and apply the limit as x approaches 0, my first fraction becomes a 1. When I apply the limit to the second fraction, my limit becomes 1. And then all I'm left with is just 1 over 2. And that is my answer. Let's take a look at number 13. Okay, so as I look and take a glance at the numerator, what comes to mind is sine squared x equals 1 minus cosine squared x. Well, I'm missing a square. So maybe if I go ahead and do 1 plus cosine squared x, and I multiply it by top and bottom, then I will get 1, because I will have to FOIL that, but once I FOIL it, 1 minus cosine squared x will be given to me. So in the denominator, I have to go ahead and carry the sine x and multiply by the 1 plus cosine x. So then the numerator, I can go ahead and replace this part with a sine squared x. And as I look at this, I'm like, okay, well, I have 2 sine x's in the numerator, which is awesome because then that means I can go ahead and cancel one of them with the denominator. Because originally, if I were to use direct substitution, I will have a 0 in the denominator, which will be undefined. So then from here, let's see, what do I have left? I have sine x on top. I have a 1 plus cosine x on the bottom, which is great because the sine is really what was giving me a problem. So then let's go ahead and apply the limit. The limit as x approaches 0, I will have a sine of 0, which is a 0. Cosine of 0 is a 1, which will just result in a 0 for my limit. Now let's take a look at number 14. With number 14, if I were to use direct substitution, it will give me a 0 in the denominator, so that wouldn't work. But let's go ahead and plug this through directly. If I were to substitute it, I have a 4 pi over 4 divided by a tangent pi over 4. Which is going to be the same thing as every time I see a tangent, I always think about sine over cosine. So I will do a 4x, or excuse me, a pi of sine pi over 4 divided by cosine pi over 4, which is going to equal the same thing as pi divided by, and when you look at the unit circle, sine pi over 4 is going to give you a square root 2 over 2, divided by cosine pi over 4 is a square root 2 over 2, which is great because this will go ahead and give you a 1, and your answer will just be pi. All right, you guys, I hope that helped. I hope that answered your questions when it came to looking at this from yesterday's notes. Let's go ahead and move on to the next part of what we're doing today. It's not letting me. Okay, so yesterday we went over your group work. There were 27 cards, 9 problems, and you were supposed to match the problem with the word to the answer, and these are the answers to those cards. So pause the video and go ahead and take a look at that. From this question, there was one that somebody expressed that they had difficulty with, which was question number, or letter G. So with a question like this, you're going back to Algebra 2 honors. You have to multiply by conjugate, which is going to be square root of x squared plus 12 plus square root of 12, top and bottom. And then you will have to FOIL it. When you first FOIL the double square root cancel, so only the content inside the square root is going to be your answer. So x squared plus 12. Outer and inner will cancel each other out because one's a positive, one's a negative. And then negative square root of 12 times positive square root of 12 is just going to give you a negative 12. And lucky for you, that 12 for the top and bottom cancels. But then also the x squared on the top and bottom cancels. So you're only left with this part for the numerator. Divided by 1, which is just going to give you this answer right here. When you plug in the 0, that will give you a square root of 12 plus square root of 12, which is 2 square root of 12. But then you can also factor or actually break it down of square root of 12 to 4 and 3. So that 4 comes out, so 2 times 2 gives me a 4. So the answer is 4 square root of 3. All right, so take a look. This is what we're going to be talking about today. And let's go ahead and get started. So first, our activity is going to be on, you could do it on a separate piece of paper. You're going to show your work on the following problem from a timed college calculus exam. I used to teach this over at TMCC, and this is one of the questions that all the calculus teachers will give out at TMCC. So you have 5 to 7 minutes for each of the following 3 questions. Here is your first one. You can pause the video, take a look at the question, and give it a try. All right, so here are my answers to that. So when you look at this, let's just draw a secant line. A secant line is going to be this red line because it's touching 2 points of the graph, and that's why I labeled it. Next, this is write an expression for the slope of the secant line involving f a plus h. Well, from this first point, this is going to be x value is a, y value is f of a. The second point is the x value is a plus h because a to the second point, this stretch is h. So a plus h will give you the x value of the second point on the secant line. The y value of this is f of a plus h. So therefore, these 2 purple writings are going to be your point. And then from here, it's asking to draw a tangent line to the graph. Here is your tangent line. And then the following, I actually have a separate video that is also posted on YouTube with this. That's going to go over these 3 questions in greater detail. So make sure you move on to the next video following this one so you can hear my explanation. Some people probably don't want to hear my explanation because they're like, oh, I got this. I see the work. I could totally do it. So I'm not going to take the time to bother you with that. But if you don't get it, make sure you watch the other 3 videos. Here is question number 3 and question number 4. I skipped the first question because it was kind of silly and you guys are smarter, far smarter than that. So pause the video, answer the following 3rd question. Here's your answer for the 3rd question. And once again, if you'd go on to the following video from this one, it's also labeled week 6 Tuesday. And it'll just say part 2 of the college question. Then you will have my explanation of this. Pause the video and go ahead and answer question number 4. And here are your answers for question number 4, which we have practiced before of interpreting how to draw this. All right, so you have this formula sheet on your paper. Make sure you are kind of getting a quick review in terms of this. And just remember, these are the 3 special trig limits, so make sure you memorize them. If you do need formula sheets, you can go ahead and go to my website. Just Google Dr.NataliaCallahan, and I have a formula sheets and theorems, all the theorems and formula sheets you could possibly need that I've collected in the last 17 years is on that page. So for your notes today, it is essentially just a review of Unit 1. You should take a look at week 6, Tuesday. This is the first review. All your answers are going to be on this link right here, capital E, capital Z, capital J. And I have my work shown on this link as well. Next, you have a calculus puzzle right here. You can go ahead and try to find some of the more difficult questions and practice with them and see if you're going to be able to get it right. Here, I have a free response question that is from one of the free response questions on the AP exam. You can go ahead and give it a try. Okay, so I want to go over one more questions with you guys on trig reviews of the limits. This is actually part of your guided notes from week 5, Friday, I believe, but it's just one question that I have not answered. So I want to take the time to make sure we go over that. And it's going to go over a different strategy that you haven't seen yet. All right, so looking at this, we probably know at this point, if I were to go ahead and do this, it's a result in an undefined. So my strategy and my goal is to figure out what can I do with this cosecant, which is new, okay? And another way of writing cosecant is going to be cosecant 9x is equal to 1 over sine 9x. If I have a sine 9x here, you know that my goal is to try to get somehow a 9x over sine 9x equal to 0, or sine 9x over 9x equals 1. I'm sorry, it's equal to 1, not 0, 1. So that's kind of what I'm thinking at this point. So let's go ahead and rewrite this. If I were to rewrite this, I have x sine, or 1 over sine 9x. In order for me to use this formula, I would, of course, need to have another 9x. So what if, let's say, I decided to multiply by a 9x, top and bottom? And it's legit because I'm not doing anything that is not multiplying by 1, and you can multiply anything by 1. So I'm going to keep this 9x right here, and I'm going to take the bottom 9x, which I don't need right now, and I'm just going to boot it out. So then what's going to end up happening is I am going to have, well, actually, I'm sorry, I don't need a 9x, I just need an x. So you erase that, just kidding, because you have the x right there. So I don't want to add more to us, so I have to cancel it later. So I have 1 over 9 times 9x on top and sine 9x in the bottom. Divided by, don't forget your cosine to 12x. So then when I go and apply this limit here, as x approaches 0, this part becomes a 1. So 1 over 9 times, I'm going to get rid of this division sign, 1 over cosine 12x, which is going to give me a 1 over 9 times 1 over 1, which is just 1 over 9. We went over this one last time. And if you need some additional practice, I do have these questions right here that you can go ahead and try algebraically using a chart or a graph with their TI-84. And you have the answers right here. Oops, let's go back. So see if you're able to get to those answers. So the review of Unit 1 is using your TI-84 graphing calculators, being able to plug in your X values on table of content, your trig limits, which we focus on the last 3 days, finding your horizontal vertical asymptote, and then of course, finding limits by using algebra, like factoring, special factoring, and then also conjugates. All right, you guys, that is pretty much it for Unit 1. I hope to see you guys next time. Have a great day.